Hello and welcome to TidyX episode 112. TidyX is a screencast where we go through and explain how our code works. And my name's Ellis Hughes.
And my name's Patrick Ward, and it's been a minute,
Yeah.
but we're back. We've been well, we had a great we had a episode on S3, then we had a cool interview with Nate Latshaw on UFC analysis, and then you were traveling to our studio conf, which you
Yeah.
did a little write-up review of that.
Mm-hmm.
I've had a lot of work, busy at work, but now we are back to continue from episode 111, where we talked about S3
110. 110.
110, where we talked about S3 objects. And now we're going to jump into an application of them. As we left off that episode, I mentioned we're going to be designing a tournament style play function. And so
Exactly.
we're going to use an S3 object as the scaffolding for us to build a tournament function where basically you input the matchups and let it roll, and it's going to kick you out the winner. And we'll talk about all the way that works.
Yep, exactly. Alrighty. So I'll drag us over here. So we started off with episode 110 creating this new object called new team. And it stored information such as the team name, the strength, and the SD. And we got a very legitimate question asking us, why would I go through the effort of creating the function that creates the S3 object? Why do I even care about S3 objects? I can just drop this into a named list. And that is totally legitimate. I totally understand where you're coming from here. I was kind of in a similar boat, and I was like, this seems like a lot of extra work, but there are benefits to creating an S3 object. And so I've added these checks here since we recorded episode 110 to demonstrate this. So these are functions that will check to make sure that the entries that we're putting into our object are valid entries. So we understand, for example, that we expect strength to be a numeric value, and we also expect it to be a value greater than 0. Similarly, for standard deviation, we also are able to enforce that it's numeric and enforce that it's a value greater than 0. And so by doing this, we're able to kind of remove a little bit of this cognitive, okay, I need to remember when I create this or when I'm doing my analysis that these values need to be this. Or you can set your assumptions that standard deviation will always be greater than 0. And so you don't have to worry about that when you're going through and writing your code and reading in data and whatnot. Because if anything is not how it should be, it's going to stop it and go, hey, you said that it's supposed to be this. It's not going forward. So that's one value. The next value is, we touched on this a little bit, but that you can create your own methods for various functions that already exist. So like I like writing my own print method for functions or for objects that I write. And so now when we create our new team, and I say, hey, when I print the team object here, I want to show me the team, the strength, and this should be the SD. So now when I create the Jayhawks and I run it and I print it, rather than printing out a list that's kind of ugly, I'm able to see in a very nicely organized way which team this is, their strength. So I could rename this to not be the Jayhawks. We just named them the Jayhawks to be simplistic, but we could call it like P. Print P, and it'll still print out all the team information I want. So I could just call it like T1 through T whatever, and it sets it all up for you. This is just one example. Obviously, we're dealing with a very simple type of object right now, but like if you have objects for like your model outputs and whatnot, which was touched upon, you can write methods for predict and whatnot, and it makes your life just a lot simpler later on. Cool. So we touched on that a little bit. So we're going to also go over, like we've got these 8 different teams that we've created, from Jayhawks to Hawkeyes, Orange Hawks and whatnot, with different strengths and different standard deviations. And so like the Hawkeyes are our most powerful or strongest team, but they're also pretty darn unreliable or inconsistent. Meanwhile, the Hockey Talkies are a reasonably good team, but are also just wildly all over the place. Meanwhile, like the River Hawks, medium team, but also relatively consistent. We created this function that runs a simulation of a team, how they think the team will perform. Then we took this and abstracted it again to go, okay, now let's run a simulation for a game, and then tell us who wins the game and return that team. So now we have all that set up, so we're able to run a simulation of the Jayhawks playing the Chicken Hawks, run it 10,000 times, and it helps if I create the various objects that we have there. And so now we've got the Jayhawks and Chicken Hawks. The winner is Jayhawks. They won 60% of those simulated games. So 61% of the time they had, based on how we calculate a winner in these functions here, they won 61% of the time. So now we're going to go, and that's kind of where we stopped at in episode 110. Now we're going to get going on, okay, and how do we abstractify this again and go up another level to actually start simulating tournaments? And so we're going to create another S3 object, and this time it's going to very simply be a list containing the two different teams. So I'm going to say, and this is also, it's helpful when you write these S3 objects and functions and whatnot. So it feels more natural when you type it. And so technically, we don't really need to create this matchup function that is just containing a list, but it feels more natural to write matchup of these two teams than it would maybe otherwise. So we're going to run that. I guess we got a little bit ahead of ourselves, because one way that you could simulate an actual tournament of four teams is you could say, okay, let's run a simulation for the Jayhawks and the Chicken Hawks, and then run a simulation for the Riverhawks and the Faux Hawks, and then wrap that inside of a run simulation to have the winner of these two simulations play each other. And that's how we can get a 4-team tournament to run.
Only works for the college football playoff.
So yes, only applicable for the college football playoff here. So we can see, and unfortunately, like you can see here, like the output is not super intuitive to read. So we might want to change this in the future. But you can see the Jayhawks and Chicken Hawks played each other, and the Jayhawks won. Then the Riverhawks and the Faux Hawks won. Here, let me zoom in a little bit. It's a little difficult to read. And then they won 57% of the simulated games. Then finally, because the Jayhawks and the Faux Hawks won, they play each other. And the winner is the Faux Hawks, and they won 57% of those simulated games. But as we can see, that's a little bit difficult to read and understand. So let's go and figure out how might we approach this more easily. And one way to think of this is to think about it, okay, so we're going to have the Jayhawks and Chicken Hawks, Riverhawks, and Faux Hawks play each other. We always know what that first round is going to be. So let's set up a function that takes in the list of matchups going, I know these teams are going to be playing each other, and the winner of these teams are going to sequentially play each other down. So let's simulate a single round. So we're going to say, create a function called run tournament round, which takes a list of matchups, and we're going to simulate the games 10,000 times. So we're now going to loop over. So this is l'apply, so list apply. So for every element of the matchup list, run the simulation and give us the round winner for each one of those games. And so it'll take it from the 4 teams down to 2 teams, basically. And this is just a single round of running. So now we've got that. So we can see that this is basically identical to running these 2 lines here. There we go. And then we get a nice list output of the Jayhawks and the Faux Hawks, as these are the 2 teams that progress forward in a round. By the way, this also has to be a single elimination, not round robin or any of the other more complicated tournaments. So now we've got that, and now we're able to go, okay, now we have a way to run a game. We have a way to run a round. Now, how do we abstract up one more level to say, now we're going to run the entire tournament? And so we're going to use this run tournament function here. We're going to use triple dots so we can just enter in all the teams that will be playing each other, or all the matchups, and then once again the number of simulations, so that we can always change that. The triple dots allows us to enter in however many arguments that we want to, and this will immediately be passed into this list. And so everything will be put together into a list, and we're going to call that matchup list. We're going to pre-specify which round we're starting at, because of course the first round, or the first layer of the tournament's always round 1. And then we're going to set up this while loop. Patrick, do you want to try to explain this?
Oh, while loops are tough. So while loops are tricky, and they are basically, let's see, what have we used? We used for loops. We've used if statements, which are basically checking a condition, and they're saying if the condition is true, do this, else do something else. A while loop works in a similar way, except that it just keeps checking that condition. And while the condition is true, it keeps doing the thing within the brackets. And once that condition is no longer true, it kicks you out to the else, in which we feed it break, which basically says break the while loop, so it doesn't just keep going around until you have to basically Control Alt Delete and shut down shut down hard. So
Yes.
here we have our while loop matchup list. It's checking the length of the matchup list and saying, hey, if it's greater or equal to 1, it means that there's more teams left in the tournament. The tournament's still going on. So while that condition is met, let's just keep on running this tournament function and keep going. So within that while loop, as the condition is met, we have we're pasting in the round number. So we're getting some information about what round we're in and where the matchups are being played, who's progressing, obviously, and which competition is happening at each round. We have this little element here, which is collecting the round winners. So we have the round tournament round function, and we're passing it that matchup list and the number of times we're running that simulation, and we're collecting round winners. And then we're also, inside of this while loop, we're using an if statement to check if, again, round winners is greater than 1. So if it's greater than 1, it means that there's still a game to be played. Once that condition is met, it means that we have a winner. Nobody else, there's no one else left for that winner to play. So within the if statement, we're collecting a matchup list, again, using lapply, which we've talked about that function before, and I just can't recall which episode, but we did a bunch on different kind of loop functions like this. So we're running a list apply. The sequence within this list is going to be 1 to the length of round winners. So how many round winners, or from the length of round winners, 1 to the length of round winners by 2. So because obviously it takes 2 to tango, so 2 teams are going to play each other. The function within this lapply is going to be a defined function rather than something that is off the shelf. And that function that we're defining is going to take the matchup list I, or the round winner, sorry, I, and it's going to play them within that matchup function. So we're just using list notation there to basically take I within that sequence versus I plus 1. So 1 versus 2, basically.
Mm-hmm. Or 3 versus 4.
Or 3 versus 4. Yeah, whatever I sequence you happen to reside in. And then the last thing there is the little rounds function, which gives us rounds plus 1, which is basically just chalking up every time we play another round. It's giving us that next count. And when those conditions are no longer met, we go ahead and we break this, and we spit out the actual winner of the tournament with their attributes, and then invisible is all the other round winners. So we're basically shutting those down. We don't want to see those, right?
Yep.
So here we go. We've got all our matchups. So if this was like the NCAA tournament, this would be, you have 4 brackets. So this would be like the top left bracket. You could put in your teams in like Duke versus North Carolina versus, the next game might be blah, 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 whatever. You get it from the newspaper and you throw it in there and you run this tournament. And if you did 4 of those, you'd have the winner of each of the different divisions, and then you'd have your final 4, and then you could play those out further, right? Mm-hmm. So here the Hawkeyes win, and if we run it again, I think the Hawkeyes are really good, so at least in our fake, lame kind of strength, it's not a real strength.
We simplified things a lot.
Yeah,
realistically, your team object might contain a lot more information about the various things, like their offensive power, defensive power, things that they're make it like a Pokemon.
But the win-loss percentage would change a little bit. Like if you run it again, you see 61, 58, and then 60, 58, 73. So there's some subtle fluctuations because, again, we didn't set a seed, so it's basically running a random simulation every time, which is cool. So that's basically how you can use that's like S3 object applied, and we built a built a tournament simulator function within that takes in that S3 object, and you could give it a shot with your your own data and maybe your own team strengths and see what it spits out, right?
Mm-hmm. Exactly. So, yeah, so that's a way that you can apply S3 objects. And that's, I think, what we have. If you have any additional questions about S3 objects, what you can do, things that you want us to see us to do with S3 or other R object systems, please leave a comment down below so that we know what you're wanting to hear about so that we can try to address that. And I think with that, I think we can call it on a very applied way of S3 objects, also Bayesian, or the stuff we learned with Bayes and past series and whatnot. So thank you all for joining us. As always, my name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And my name is Patrick Ward. You can find me on Twitter at OSPPatrick. You can find the both of us on Twitter at tidy_explained. Tidy.explained@gmail.com is the email account if you wanted to drop us a note there. But the most frequent way is people go on YouTube and they plop a comment down in the comment section below. And if you find this screencast valuable to you and you want to support our work, we do have a Patreon page, and we greatly appreciate anything that you'd be willing to contribute.
Yes. Thank you all so much, and keep on exploring the world.